So I want to go over quickly the way to test to see whether or not you have samples that are independent from one another. I'm going to use the legacy versions of chi-square. I like to use them because they're simple and they often get me the results I need. So, you you'll in the other video you'll see a different method of using it. In the lecture piece, I showed you the M&M example, and I have a data set here with a bag of 100 M&Ms and of different colors. And if you check the data set, it's very simple. It's just simply listing the number of M&Ms that you have, and each M&M represents a different line. So for chi-square, it can't handle the text, and so you need to do a recode on this and give these numeric codes. And go to data, analyze, data transform rather, automatic recode. Give it a new name. Add that name, and then click OK. And then what you get is not only the recoded data, you have a new column of coded data, but you also have a key that will be handy later. Always save this so if you do a recode so you know what those are. Now we're actually ready to do the chi-square. And one of the first ways to look at this is to say, okay, there are equal numbers of colors in each of M&Ms in each bag. And that's a fairly easy way to test, although the menu is buried way deep. It's analyze, non-parametric test, legacy dialogues, chi-square, and while you're at it, get the descriptives, click continue, and it says that all categories are equal. So that's the first piece. Click OK. And the results you get test whether or not all these categories, what you observed, matches what you expect. And it tells you how high or low those are. And the null hypothesis is that these samples are not independent and that they should be the same. And the alternative is that they are different. And the chi-square is 4.5, p is 0.477. So what we can do is we can say that these are not different, right? So we fail to reject the null. What that will mean, and how I usually do this in class is we decide whether or not, okay, if it's within specs, we keep the assembly line running. If it falls out of specs, then we stop the assembly line. It costs money. And so when you do random samples like this, it's a nice quality control piece. All right, so that's that's assuming that they're equal. But if you remember from the lecture video, these are not equal, right? There are these numbers. And so what you want to do is you want to come back and test this again using those numbers. And so we're going to shrink this down a little because you need to see this. Go to analyze. Actually, we need to see this as well. You see all of these things. Analyze, non-parametric tests, legacy dialogues, chi-square, and again you want to use this, but now we have to insert values, and the values are really important that you get them in the right order. So you have to do blue first, which would be 24%, add that, brown brown next, which is 13. Green next, which is 16. Orange next, which is 20. Red next, which is 13. And yellow, which is 14. And if you had, and I conveniently did this with 100 M&Ms, so these percentages work out. You would need to work out, if you had an odd number like 87, what 14% of 87 would be. That would be on you. I try to keep the math simple here. All right. All the other things hold. We're going to click OK. And what we wind up with is what our observed values are. Given the numbers we inputted, what the expected values are, and those match the percent, and how much we overshot and undershot. So in this case, you know, if our null hypothesis is that there is no difference between the observed and expected values, they come from the same distribution. The chi-square says that the value is 3.5, p is 0.6, we'd fail to reject that null as well. So in this case, the M&Ms, you know, match what we're expecting them to be coming off the assembly line. Oftentimes, if I'm doing this in a classroom and I've got 25 students, everyone has an individual M&M bag. Usually about 3 or 4 of them are off. And not because of anything other than, you know, small bag is a small sample, and so it's easy enough for a number of them to be off. And so you can see that there would be a wide variation in those. Your turn to go home and open up an M&M bag and test this for yourself.